So make sure that you've got that planned. Make sure that you've got the APIs in place. That's probably a big thing that's driven everything over the last year for us. So, in summary, be prepared, listen to your team more than anything, whether that's your engineering team, your sales team, whoever that is, listen to everyone, listen to your customer. Try and relate it to something to something they know, especially when you're doing new things. And always don't try and reinvent the wheel. There's a lot of software out there. There's AWS doing some great things. There's Google doing some great things. Don't try and build a security package yourself. You probably hear it every conference you'll ever go to, but there's no real need. Try and choose the right thing for the right job and add value to where you really are adding value, and that's the business logic and everything else. So that's it. As a little starter from the lessons we've learned. Any questions, thoughts, comments? Sure.
Yep. You mentioned GDPR that's coming next year in May, and one of the things will be the right to be forgotten and data portability. So that probably affected you a lot.
Yeah. Right to be forgotten is a really interesting one. Because that, especially when it comes to enterprise, because you have to be able to clearly say who owns that data. And in GDPR, it's still actually unclear who owns the data. So if someone was to put your information into a system, do you own that data, or is the person who put that information into the system own your data? And that's where it comes to data processor versus data owner and these sorts of conversations that we're having and will continue to have probably until May next year when it actually all goes through. But there's a lot of work that we're doing behind the scenes to be prepared for whichever way it goes. Anything else?
What is your background? Are you more engineer or programmer?
I am very much in the engineering camp. I was lucky enough to join as I said, I went to gambling pretty much straight out of uni, and we tried every language, did a bit of this, bit of that, and learned a lot and trying different things. Everything was around choosing the right tool for the right job. Back then, Java was too slow, so we actually weirdly used a language called Tickle and wrapped it around C to get the scripting. A bit like, I guess, what Go's doing these days. We did things like our chat server was written in Erlang because that was the best thing at the time to write a chat server in. So, and we did a lot of different things, just choosing the right tool for the job and knowing what the underlying structure and everything else was.
Do you use special tools to protect or monitor cloud application?
Yes and no. We rely a lot on AWS. AWS is pretty fantastic out of the box. If you adhere to their best practices, you read all the documentation, you have chats with their engineers, you can pretty much get it to do everything that you want it to do. We supplement it with things like OSEC HIDs and some other little bits and pieces around the edge. But actually, it does a lot what you need out of the box. They're adding, new features at an insane rate. My biggest, I guess, problem, if you want to say it like that, with AWS is typically when they do release features, they're not quite ready. So they're just trying to get that real MVP out there, get it used, see how people are using it, and so we use things like the WAF, the web application firewall, and things like that, in conjunction with our API gateway. So sometimes you have to just work around some of the newer stuff that's coming out, but they do a pretty good job.
Another question.
So we
asked on a registration form how you would write high-load startup, which technologies. So if you forget everything you have done at both guides and started tomorrow or maybe even today, what would you choose? So on the back end, what would you do on front end? How you would deploy that? Discuss.
Sure. It's a really hard one for me because I think you get a lot of benefit from Java. There's so much stuff out of the box, but there are a lot of other languages that are catching up so fast to what it is. If you would have asked me that question 6 to 9 months ago, I would have probably said Python. I'm a big fan of Python. The biggest benefit I think you get from something like Python or any sort of more scripty type language is the speed in which you can write everything. I think when you're at an early stage startup, you're going to get so much wrong, it's insane. We got the amount of business logic and everything else we got wrong was just insane. You're constantly reiterating, going over, changing it, adapting it. Writing that sort of stuff in Java is actually quite cumbersome. So you do have to weigh up that, okay, we're getting all this good stuff for free in Java, but actually I just want to get this thing done. Other end of the spectrum with Python. I think there's a lot of good stuff going around in Go at the moment that actually starts to kind of give some of the free stuff that you get with Java over to Go. A lot of people are contributing libraries and everything else like that. I think, and we might start playing around with Kotlin, the IntelliJ language, because that kind of, it was like, to me, Kotlin seems like, back in a couple of years ago, I started playing with Joonathan, just as a kind of a hybrid mix of, okay, I can get all my free stuff that I get with Java, but I want to write it really quickly. Kotlin seems that kind of mix that we might be able to get to that nice balance.
And for the web?
For the
Web.
For the front? I would probably choose, I mean, it's hard between React and Angular, right? Because I think they're both great frameworks. Me, as a hiring manager, hate React. There are too few React developers out there. Angular, a 10 a penny. So that from a hiring manager's selfish point of view, definitely go Angular. I think probably React is a slightly better framework. So yeah, everyone learn React, and I'll be happy.
But React contradicts big deal with what you mentioned in your talk in terms of licensing. They had this thing going on in the internet.
I think that will be resolved. I think there's too much that actually uses React now. When it gets to that, like I think there was a court case in the 70s or something like that was, can a generic vacuum cleaner be called Hoover? Because Hoover was that particular brand. It kind of reminds me of that particular thing. It's like it gets to a certain point where they can't really enforce that anymore, and I think that's what will happen with React. I think it's got to become more open and more usable out there. So yeah, I'm hoping that's, as I said, it's a slightly better framework. So I'm hoping that's the way it goes. But as I say, Angular is pretty good, and we're pretty happy with it. So
That was a lot of great information you say for people involved in startup. But mainly, as I understand, that's purely software related. Any extra advice you would have to add to all you have already said for the company which deals with hardware and software? Looking back, what we are.
Dealing with hardware as well. I don't think. I think all the principles are still the same. I think empathy. You've got to realize the hole you're filling, why people want your software or hardware, Why do they want it? What does it give them as a benefit? And also, what are your constraints? You know, what doesn't it give them? What can it cause to go wrong? And I think as long as you have this empathy with your own stuff, I think it goes from everything from hardware to software. I think the biggest challenge I would say to anyone providing hardware at the moment is you've got a lot of competition from the cloud. You've got a lot, you know, AWS, Google, Azure, they're all doing fantastic stuff. And it's going to take something special now for people who's either starting something up or even going to a new project or whatever it is. A lot of these big enterprise companies are kind of, I wouldn't say giving in, but they're recognizing the fact that in order to retain talent, to get new talent, in order to be able to challenge and take the risks, they're actually almost spinning up mini startups within the big enterprise companies. So you still get this startup atmosphere. And I think these guys, when they're choosing to do something, they're choosing to do it in the cloud. So I think it's a really hard sell now. You have to be pretty specialized in what you're doing with hardware to actually, I think that's the biggest challenge for anyone supplying hardware these days, is having that the competition is much more fierce, I think.
I think that's it for the questions. Thank you, Steve, so much.
Thank you.
Now we have 10 to 15 minute break.
Yeah.
Never started, you once destroyed a broken heart that was already shattered. Holding on to what we have and take us to the edge and back. Holding on to what we have and take us to the edge and back. This love that you never started, you once destroyed a broken heart that was already shattered. Holding on to what we have and take us to the edge and back. Holding on to what we have and take us to the edge and back.
lately forgiven. Gave my name to all of them. Gave my name. And the worst of it all is that I can't keep my heart straight. Keep giving, keep giving. And the worst of it all is that I can't keep my heart straight. Keep giving up.
I got trapped in your eyes the moment you looked at me. From across the room, those eyes kept following me. Something popped in my brain. No, baby, only you I see. Feels like I'm going insane, and only you can save me. Feels like I'm drowning in ocean's blue. Baby, come on, baby, baby, come on, let's go. I'm losing control over lights in this space. Keep jumping around, all I see is your face. But you're moving closer, no time to escape. Your hand on my shoulder shoots me into space. And I can't deny how badly I need you now. led me all the way to the ocean sand. You told me don't worry as the moonlight gled. I pulled you in close, so whispered I'm not scared. I'm losing control, the lights in this place keep jumping around, all I see is your face. But you're moving closer, no time to escape. Your hand on my shoulder shoots me into space. And I can't deny how badly I need you now. 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 I need you
If it's silent in dismay, it won't break this feeling down. If I conquer this my way, I'd devour, I'd surround. If it hurts you just a little, then it heals you when it's done. Disappointment is the anchor, resolution is the sun.
Mostly because it happened to encourage this component-based architecture. And so far, we've found it to be the best approach to building complex and most of all scalable front-end applications. I'm sure there are more, but and this is definitely not the one true way of building front-ends, but it's been very useful to us. And I think this kind of pattern is not limited to React, but similar concepts are in Vue, Angular, and now with web components in web standards. So to start at the very basics, like what is a component? I think Lego blocks are very good examples of what a component is. Like it's a small building block with a well-defined purpose and a clear interface. So it means you know what the component does and how you should use it in an application. And typically it handles some kind of logic and renders stuff. Stuff can be HTML or other components. This is still pretty abstract, so we can walk through how a simplified version of a component we actually use works. So this is a select component, which basically renders a select box with some options. It has a pretty simple interface. You have a value, you have an onChange function that basically tells the parent component to update the value, and you have the options that are rendered here. if we take a look at inside this select component, this is pretty much all that it does. It renders these options and another component called styled select element. So it does one simple thing and passes everything else onto another component. And this styled select component also does pretty much one simple thing, which is render a select and attach a class, which ties back to the style element there. And the select itself renders the HTML element and attaches these React values and event callbacks. So to recap, select renders the options, styled select the styling, and select the actual HTML element. And this is what we get in the end, which is slightly more complex than the simple select interface we had here. Now, if we take a step back, there's a pattern emerging here. So essentially, we're building more complex components out of simpler ones. We can do it layer by layer, and each layer handles a different concern. So we can use the same select component we built and make it into a date select that just puts 3 selects here and allows us to select the date. And this is pretty much what the interface there looks like. And this makes intuitive sense for shared components. We want to have a library of small bits and pieces we use everywhere in our app to ensure consistency and so on. But why stop at shared components? So what if the entire app is components all the way down? And that basically is the essence of the component-based architecture. So you take your big app and you slice it into small logical components. Each component handles some of the functionality and hands off the rest onto other building blocks. And the components are encapsulated with well-defined interfaces. So basically, to the parent component, the building blocks are like small black boxes that only get interacted with by the interfaces. So this sounds interesting, but why should you actually use that? There's another interesting property that kind of emerges from this design is that complexity doesn't change too much as you go higher in your application. So, for example, this more complex select-based component doesn't have an interface that is it's not more complex than select itself. If we take a more involved form here, which contains 5 different inputs, this is also basically a very simple interface. So there's a value, there's a callback to update the value, and some parameters to set the limits and currency. And this tends to hold true on almost all levels of your application. So basically, this actually is an aspect that isn't talked about too much. Like, I think the biggest value of a component-based approach is that it reduces cognitive load. It helps us break huge applications that are complex into manageable chunks. Basically, it helps us with the problem that we're all basically naked apes mashing buttons, and we have, fundamental limitations on how much we can understand at one point. So small components are way easier to understand and reason about. And another useful thing is that the same pattern of building stuff, so decomposing it into components, applies from the smallest element to the highest levels of your app. There are other benefits as well that stem from the fact that the components are simple and pretty small. So they're harder to screw up than big things. They're easier to test because components usually do one fairly simple thing. Easier to refactor, and as I mentioned before, they're easier to understand. So you can basically hold the entire component in your mind at once. And it's also pretty useful for code mobility. So components with clear interfaces can be reshuffled pretty easily. So this is both within a single project or between similarly set up projects. There's a caveat here that if your stack evolves quickly, your different projects can get out of sync. So one uses, for example, SaaS style sheets, the other one style components. And we've had a lot of problems with various slightly incompatible sets of TypeScript settings. But within like a reasonable stack, it's pretty easy to move components into other places. The consequences are that you can make changes to your app pretty quickly, and you can build new things with existing pieces. And this has direct consequences to delivering actual business value. So an example from Teleport is that we built these city pages that contained a bunch of different widgets that surface data to our users. And one day someone bounced this idea in a chat, like what if we built a tool for recruiters and HR people to send to the candidates who are moving to new cities. They might not want to visit the full Teleport site. Also, the HR people might not want to show them the salary widget, for example, for various reasons. So within like an hour, we actually built from the components we already had this customizable report builder. So everything you see here was basically the same code that ran on the city page, but just put together in a different way. So the Lego analogy is pretty good, pretty adequate. Yeah, this was the overall concept of a component-based architecture, and there are a few things we've found especially useful on the way. So how you organize components is also important. This kind of layout that we've finally gotten to. So it's basically single file components with a main component and styled components, which are just the small styled selects and stuff like that only attach styles. And there are co-located assets and tests. So basically there's a small folder that you can drag between projects, and it should contain everything you need for that component. Another very valuable asset has been TypeScript. So it helps describe and actually enforce component interfaces. So and also it's kind of documenting the code as well. So this is a interface for the props for the select component. And if you use it wrong, like forget the prop or put a number where it shouldn't go, IDE will tell you. And catches errors very quickly. Also helps in refactoring. We used to have a lot of bugs where an API changed, for example. We had to manually find all the places where that API was used. And sometimes when you pass data through various layers and components, it can get lost. So TypeScript has been very useful. Another thing that we use a lot and have started using recently is style components. And this takes every component should have a purpose principle to the tiniest basic blocks. This is a way to add styling to various HTML elements. It's very convenient, very quick, but most importantly, you kind of have to think about why stuff is there, because you have to give names to your style components. So, not too proud of it, but there used to be times where I added like 5 divs inside each other and it didn't blink. But now when I'm naming the 5th component something wrapper, I kind of start to think, like, maybe is there a better way to do this? So you have to assign like meaning to all the components you're using. Something that's kind of funky is React Router. So this, the latest version of that kind of turns routes into components as well. So you used to have this routes file where all your views and stuff was routed. And now you can use these components that you can put pretty much anywhere in the app. So you can have this base level app component that routes the views, and that's it. And the views do internal routing within themselves with another bunch of React components. And you can do all kinds of levels of hierarchy like that. It's the same basic principle of handling one simple thing and then handing the rest off to child components. And the last thing is distributed data fetching. This is actually an in-house framework we built. But since we used, we ran on a microservice architecture teleport in these days as well. And we had a bunch of different APIs. And a lot of the components, like the widgets, pull data from very, very different sources. So we found it to be much easier to co-locate data fetching with widgets. So all of the widgets define the data they need, and they get fetched by the component. So instead of managing data centrally, kind of have a mechanism centrally to fetch data, and widgets say just what kind of data they need. And this solves the overfetching problem as well. So we don't want to fetch all of the data we might ever need in the application at once, just the bits we need. And also that data requirements are defined where it's actually used. And that's pretty much it. Are there any questions or suggestions? Yeah.
The components you're building, once you have a hierarchy of those, there are times when you need to send like commands or messages to the, let's say, child components, and there is not like a very intuitive way of doing that. Or what's your experience with that? I mean, you can declaratively specify the attributes of that, but sometimes you want to like send some messages or commands which they need to react something, like change its internal state or something. Have you any thoughts on that?
Do you mean through a big layer of other?
You have like a, I don't know, maybe like the example with the date selector.
Yeah.
So you want to, well, an easy example is that if you want to change the date, then you change the values of the attributes basically.
Yeah.
But let's assume you want to do something more tricky, like highlight a range in the displayed calendar or something. So, and maybe it has several of these options, like it has different ways of doing things. So what I've experienced myself, not with React, but with a different framework, but I think the idea is the same, is that while it is relatively easy to declaratively specify the data attributes, once you want to, like more richer communication with the component, that kind of, there isn't an easy solution for that.
So there's Redux for, we store, for example, the data that components fetch, we store in Redux. That's shared across all the components. So I think
it's basically like, could a component have an API, like expose an API, and it's besides the attributes that you can declare. That's like the fields you can change, but besides fields, you would want to have some methods, like do this or do that, and that is a little bit tricky, I think, for web components with any of those frameworks.
Okay, fair enough. So I think there's still a lot you can do with properties or the attributes you set.
You can work around things with that, but what I'm wondering, have you any like experience or thoughts around that?
Not really. So a lot of what we do is at Teleport anyway was displaying data. So it was very easy to write components that were basically a function of their properties. And if there was some kind of functionality in the components, you had these handler methods that you pass on to the component, and then when something happens, it notifies the parents, and that triggers the data flow again. But I know there are various frameworks for that, like Redux, for example. Components can dispatch events, or there's Redux sagas as well. So there are, I think, a bunch of ways you can do that. But yeah, I don't have a specific answer, sorry.
The question about these changes of frameworks that you showed in the beginning, when you change it from the SaaS and this to the styled components, was it hard to kind of move from this way? Is it difficult to update your frameworks to the styled components? I mean,
not too difficult. It was slightly annoying because we had to name all the HTML elements we used and move the bits and pieces from a style sheet into different locations. But yeah, it just actually for the switch to styled components, we mostly just started a new project with it. Okay. Then we had some components that we had to bring over and did them one by one. So there wasn't actually too much conversion going on.
So it's better to start from the beginning. Yeah.
Oh yeah, definitely.
You mentioned the reuse by copying the component to different projects. Is it like an ordinary way how you do it, or is like a shared component library which you include every project, or which way you do it?
So for the switch, for example, to the latest the styled components thing, we actually copied them over. But we used to have a UI kit library that was published on a private repository on NPM. Same for APIs. So we had like 4 or 5 front-end applications. They all shared the same UI components and the same API methods. So I think that was we tried different things, but that in the end was the easiest and cost us the least amount of sleep. It got also pretty complicated with TypeScript typings for a while, but these days it's pretty nice.
So we would suggest doing that.
Yeah.
Copy. Okay.
No, like a shared package or something.
Okay.
And it's a lot easier if you're using some kind of typing overlay like TypeScript or Flow.
And you answered for the first question with Redux Saga and how it's better than just using this kind of new thing, that using these generator functions. Does it help much?
We haven't used it too much. You can do interesting stuff with it, but for our use it's too complicated. So we don't even use regular Redux too much now. It's kind of a backend for the data fetching framework, but that's pretty much it.
I think that's it with the questions. Thank you so much.
Okay. Thank you.
time to breathe. This is our identity. We can't help, we're gone. This is our identity. Take my hand and we'll go away to a different place. Float on air and we'll hide away. I'll be your escape. Look up and feel the shifting winds tossing us around again. Hold tight, get ready to begin and just levitate. No control over where we go, but we don't care to know. Ignorance is bliss. Your tears are gone, and they drifted back from where they came, and they will not be missed. Look up and
Don't try this yourself. It's extremely dangerous.
This one is more back-endish or maybe infrastructure-ish, I guess.
Yes, a little bit more about infrastructure, and it might be the shortest one today because
Joonathan on the stage.
So thank you. As I said, the security around containers itself is actually quite complicated and deep topic, and we could go on for hours here. First on the containers themselves, host security around them all, coming down to monitoring and everything. But I suggest to get started, let's start up. What are the containers themselves, and where they might be useful. So, in a simplified form, we can look at containers as a solution to a problem on how to get software to run, reliability in all the different computing environments that you need the software to run. So, the software usually starts off from somewhere from developer's computer. It needs to move on to the test environments, and from there on to production in the end. And in the cases of enterprises, they might have software already running in somewhere in physical data center, and containers might be useful there to help move these applications to public cloud or even to private cloud in some virtualized form. And then what does the container actually consist of? So container consists of everything needed to actually run the application. And that includes the runtime environment, the application itself, all its dependencies, libraries, other binaries that might be needed. They are all bundled into one single package. And this one single package actually shares the system's kernel with all the other containers running on the same host. And by running containers, you actually gain additional layer of isolation. And then this layer of isolation can help you live safer in your environments. And of course, containers help you to ease the application development lifecycle, make it faster, make it leaner, as you can reliably, hopefully, deploy the same container to all the different environments. Some security benefits that come with containers and usually with the architecture around the containers, especially if we talk about microservices, are the smaller attack surface area, shorter lifespan of the actual deployed versions as it allows to go quicker, you fix bugs faster, deploy a new version, and in general we see more automated processes around containers as well. But of course, some of these points can actually be also the negative sides of containers. So smaller surface area can mean that actually you're creating more complex environments. You have more different containers talking to each other. You need to understand the environment and the complexities. Shorter lifespan and the fact that mostly containers are being used in a stateless form can mean that it's much harder to actually debug what's going wrong with your applications if the containers come and go and you don't have your logging sorted out, for example. And automated processes kind of have similar effect that things can just happen without you being in control in cases where you don't think about those things. And as I said, in most of the cases, containers are considered to be ephemeral and stateless. So when we continue with the talk as well, I don't really necessarily touch any state in these topics. So if we go into container security, then containers actually are making use of quite several technologies that have existed for quite a while. So we start off with building containers on top of Linux kernel namespaces. And namespaces are the components providing the isolation that everyone cares about in containers. We talk about Linux control groups, or C groups as they're called, for resource limitations. So you don't want to have a runaway container consuming all the memory or CPU on your host. C groups come into play there. We're talking about Linux capabilities, and this allows you to fine-tune the privileges that containers are actually capable of using. So here we can limit file system I/O access, for example, or access to raw sockets or anything like that. And also we are seeing more and more containers leveraging even more finer grain kernel securities via AppArm or SE Linux and GearSec and other kernel security modules. And by today we can say that containers by default out of the box in most of the cases as containers themselves are quite secure. We see huge security teams working around Docker, around infrastructure automation tools and Kubernetes and everything. So people are paying attention and are being very sensitive to security issues there. And but the one thing that can change it easily and something that you necessarily need to keep on mind is that if you start running privileged containers, this is easy to change, and privileged containers cause a lot of trouble. So if we talk about container security, we have to touch on the hosts themselves as well, where the containers actually run. And in a simplified form, you can think of the hosts as a standard servers as you have been operating day in, day out in your life. You still need to patch these, you need to pay attention to the security, but there are some additional things that can make the environment more secure. You can actually fence off the host as it is totally, and then just leave it available only for some back-end access network where you just can do your administration tasks. You don't necessarily have to give SSH access to all your developers to those boxes anymore, and things like that, because usually containers have their separate networks where they sit. As I mentioned before, really watch out for privileged containers. Privileged containers can do pretty much anything that could be done on the host machine itself. So one interesting example here is that within the privileged container, if we talk about Docker, you could do Docker in Docker. So it's a way to go for the inception. And if you're using an orchestration layer on top, for example Kubernetes, and you need to run some privileged containers, whatever it's doing, some security daemon or anything like that, then Kubernetes actually has an admission controller called deny escalating exec, and this actually restricts attaching to the privileged containers and running exec on them as well. So this brings some additional security into the world where you still run privileged containers. Security about images. So images is the easiest way to get something bad into your environment. And if you don't pay attention of where do you get your images from, you can face a lot of harm. So the simplest thing here is make sure that you know where your images are coming from. Hopefully you get them from the private repository somewhere and you have put them there yourself. You can make use of the Docker Trust frameworks and everything like that. But even if with the known images you use, it would be good if you would be using something like Clear or then Docker Hub is providing security scanning capabilities as well, because these are like statical scanning tools that take a look at the CVE databases and everything like that, and make sure that your images don't include anything that could be vulnerable. And then CVE database today contains around 90,000 different vulnerabilities and issues. So there's a lot of things that could be happening within your images that you run today. If you are sharing your cluster or the host machines with some other teams, then in cases like that, it might be useful if you actually force your containers to always pull fresh images. And this means that no other can easily make use of the image already existing on your host machine, and then just using that to boot up their own container and so on. And if you're using orchestration layer like Kubernetes, you could also pull in image policy webhook admission controller, and this allows you to do very fine-grained control over the images that you actually would be executing on your cluster. You can take specifically build whitelist, blacklist, or anything you want to do. You can take a look at which Docker image layers are being pulled from where, and then so on. And then one good thing to keep in mind with images is that keeping images as small as possible is also good for security, because the software really can't be vulnerable if it's not there. And please don't bake any credentials or anything like that, anything sensitive into your containers and container images, and try to fetch that information separately. Kubernetes is providing config map and then secrets capabilities out of the box. Make use of those, and then please don't put anything into the images. Security of the network. So today it's also relatively simple already with your containers to make use of different network policies. So you can ensure that containers can actually only communicate with other containers that they need to communicate with. You don't need to make container to container to container network wide open within your cluster, because that allows one compromised container to actually make a lot of harm for all the other containers as well. Again, Kubernetes is providing network policy out of the box. Currently that is ingress traffic rules only, but it's label based and then very easy to configure. And if you are looking for finer grained controls, then Project Calico, for example, is a very good alternative CNI plugin. And to actually secure service-to-service communication, then service mesh tools like Istio make that relatively easy as well, by taking care of, for example, mutual TLS, CA, and things like that. So resource quotas, I briefly touched on this before as well, but this is actually something that people, in most of the cases, actually miss. Out of the box, no one really defines resource quotas. So the container can take whatever resource is available in the host, and by this cause noisy neighbor, or in the worst case, denial of service to other services on that host. And again, Kubernetes actually allows to define resource quota policies on the namespaces that get applied by default. You can use admission controllers to enforce even finer grain resource quotas. And this all actually ties down into the C groups on the kernel level. And one of the most important points here is that plan for the attacks. Hopefully nothing really happens, but if you don't think about this, then when something happens, you're in more trouble than you might be elsewhere. Investigate how would you actually, find out how would you actually investigate potential attacks. Make sure that you're actually logging everything, and then the logs are stored in some central location, and then actually go out properly outside from the containers. Think about whether you can somehow snapshot the problematic containers to actually investigate these in details later. And then make sure that you understand what information actually lives on your host machines, and then within the containers, if you store anything in there, God forbid, but what's your recovery plan for all of that data. So the basic recap around here is that you should really try to prevent unknown images. You should continuously scan for the images for vulnerabilities. I'm pretty sure that you still can find images that have Heartbleed, OpenSSL libraries baked into them. And you don't necessarily even bring that in meaningfully by installing a vulnerable application, but it's just some library that at some point got compiled in somewhere. Stop privilege escalation if possible, and if not possible, use the capabilities around it. Enable only the capabilities that your containers require. So if you don't require allowing file system access, write access, for example, you can actually disable things like that there on the capabilities level as well. Enforce network isolation, so no bad actor on the network can harm your containers. Protect host resources. Encrypt sensitive information, so this means all the credentials and everything, and inject these via other means than baking them into the containers. And enforce use of automation tools, and tie these automation tools into your monitoring system so you understand when actual deployment was made. So you can go back and look what happened after the deployment, and if you're debugging anything, this really makes things simpler. And then by this you provide visibility across the environment, so you know where this specific container image has been used before. You can see whether it was used in test environment, did it see similar effects, or this is now new and happening only on production with this image, and so on. And Center for Internet Security, CIS, has actually put together benchmarks, pretty much just a nice word for huge documents that describe how to safely run Docker and Kubernetes in your environments. But the nice thing about that is that now people have built automation tools that help you to validate that your environment actually is built as the benchmark says it should be built. And these usually give really actionable insight, something that you could just go and then change and make your environment safer. So just few tools for you to use and check out. And yeah, this is it about container security. It's relatively short. We could go on for hours, pretty much on every single slide of this, but I'm happy to take questions as well.
Today is the second talk. We focus on security, so I have to ask.
Sure.
Have you been penetrated? I mean, in a nice way. Like
Is there a nice way?
Like, and how deep it was?
Teleport has not been penetrated, and I believe Giles can comment on Move Guide's history, but
No.
hopefully not.
Thankfully.
What I can
At
comment.
least some attempts. Like, have you mentioned that? That was like initial question.
Teleport has seen
How you
attempts.
mentioned that?
There's always attempts. You can see it in our security alerts and the logs every day. People try and get into the network on average once every 2 minutes, 3 minutes. It's, you know, there are people malicious out there that they're just scanning whatever they can scan. They're trying to do whatever they can do. You have to protect yourself, and you have to be sensible. It's about, you know, I said earlier, making the attack surface as small as possible, and then once you know you have to have that little bit open, protecting that, alerting on it, finding out from the noise what actually matters. And so you do see it day in, day out, that there are people trying to do it.
And there's a lot of, like, it's a business on its own to actually scan you and then try to make money out of that. So you can easily see guys from India writing to you that they are willing to provide you some security insight, and they have done some scans on you and stuff like that. If you actually go into logs, you can see what they have actually done and so on. So people are trying to scam that space as well. Yes?
So you mentioned the snapshotting, the malicious or problematic images.
Yes.
For actually Docker containers.
Mm-hmm.
Is like there a tool available, or should I basically scan, look for the Docker storage of Docker images?
You just look at the storage and you just pretty much copy the layers away.
Okay.
Yeah, there's potentially, probably there are some specific tools as well, but they don't really do anything else.
A question here, please.
On one of the slides you mentioned that the smaller the image is the better. So what is the smallest image you can...
Smallest image, probably some very tiny statically linked binary that you just execute. So if we talk about Go programs, for example, then Go programs can be compiled into statically linked binaries, and you can pretty much put these into Scratch containers. If you need to talk to some external parties over SSL, you need to add some CA certificates to that as well, but on the average we can talk about megabytes there, depending on the actual application.
But the base image, what is...
Scratch container is pretty much just an empty space. It's nothing. If we talk about like more fully functional Linux, we start getting into the Alpine Linux, for example, and even then it's tens of megabytes potentially.
A question from my side also.
Yes.
You mentioned that you encourage to scan the images you're using from open source, presumably for vulnerabilities.
Yes.
Well, did you ever have you ever found anything vulnerable from there, like on your practice?
I think
how big of an issue is that?
I can't remember anything, because like some of the teleport stuff are really running on Scratch containers and pretty much something very slight but slim. But the Clear project itself, I believe, and Aqua Security, for example, have put together a lot of presentations on these when they scanned the whole public Docker hub, for example, and then just exposed the CV database vulnerabilities, and there's currently like 90,000 CVs available, and the number of vulnerable images was huge.
Okay.
So yeah, please be aware and take a look.
Were there any well-known and
I think
widely used ones also?
I think potentially it really, if people at some point in time have built something on top of Ubuntu or Debian or some of these huge distro images and have just kept building on top of these without upgrading the underlying image itself, there still could be some Heartbleed or Ghost or stuff like that in them. And then Clear is a very good open source tool from CoreOS for running those scans. And if you're running, hosting your images on Docker Hub, for example, and have paid Docker Hub planned, then Docker Hub actually provides this as well.
Okay.
So it's really easy to get started with scanning there. There's no excuse.
Okay, that's good to know. There was a question.
Yeah, I have a question. How do you protect your public services and API from DDoS attacks?
So for example, on the Move Guides side, we are using Apigee, and then pretty much manage to offload taking care of the DDoS by just using some provided service.
So you basically manually trigger traffic for your
Yes.
DDoS provider in case of the
Yes.
attack.
Yes.
Amazon are actually pretty good at doing it these days. DDoS protection has been on by default standard for over a year now. Amazon came out with a product called Amazon Shield that they actually put in front of most of their load balancers, things like WAF, which is their web application framework. So anything that you can potentially put out to the outside world via Amazon will now be protected by Shield.
Yeah. And
Not exactly, because if there will be targeted attacks on your API calls, for example, they will find out what is your heaviest API calls and just issue a specific number of them. They could easily take down your service, and it will be not DDoS attacks on Amazon level.
But this is something you enable the throttling on the API gateway side. So this is something that the API gateway, and as Giles mentioned in his first talk, choose your API gateway wisely, and that this is exactly the reason. Yes, you could be running your own API gateway, you can build something on your own, but if there's some service that can offload some of that pain from you, then
you have to. I mean,
makes
we
sense.
mix this Apigee and WAF together to find the best blend when it comes to opening the APIs up, and they all have this DDoS protection, rate throttling, everything you need.
So you actually had DDoS attacks?
During teleport days, we have seen heavy traffic that can be considered DDoS attacks. Yes, in most of the cases, there are not really been just to harm us, but people, for example, crawling data at rapid rates and stuff like that. Because teleport public APIs contain a lot of information that we're not really restricting. Then some of our competitors and people just out of the interest have gone out and crawled that at very high rates, and that can cause some issues.
What's the best practice for any application that needs a virtual machine like a Java or Python or Ruby or whatever? Do you bundle the virtual
VM
machine itself in the image, or?
Yes.
Yeah.
VM goes into the image. There's no sane way to share the VM
So
as such.
how is it usually, or whose responsibility is to keep the VM up to date in that case?
So ideally for the application there will be base image provided that already has the VM in. So usually it's still the developers themselves, because they know which Java version, for example, they need. They actually build the final images. So they need to keep their base images in line with what they require. And all the security, vulnerability scanning and everything like that, that should happen quite transparently for them. They should be aware what's happening, and if they have any vulnerabilities, or even if they accept some of the vulnerabilities, but someone else shouldn't be building the images for them.
I remember by CoreOS there was also a container registry service. I can't recall the name.
Yes, I can't remember the name by heart either. They
But
have the clear capabilities built in.
and they also, it was over a year ago I think, and back then I remember they also offered the security checks on your images.
Yes, it's pretty much the same clear that they have provided as an open source. It's built into their platform offering as well.
Do you have any experience passing security audits with containers?
Not yet. At Skype we did somewhat pass some security audits with containers, but that was containers, but purely on the LXC front. So Docker was not still a thing back then.
Okay then, guess that's it for tonight. Thank you so much.
Thank you.
Beginning of October 12th, I guess it would be. So see you then. See you there.